Okay, good morning, grade 10s. So we are starting Unit 6 now. So I'm going to be going over the notes for Lesson 1 of Unit 6. We did all of Unit 5 online since we left school. So for Unit 5, if you go to the website, you'll see a bunch of lessons. And at the end of all of those lessons, I posted kind of a final assignment for Unit 5. That final assignment, I encourage you to complete and hand in because I will be correcting those. And if it boosts your mark in home logic, I'll enter it. However, if you don't do well on that assignment or you don't hand it in at all, don't worry about it because I won't put it on home logic. We only enter things that raise your mark. But I do encourage you to give it a try so I can give you feedback at least on what you did wrong and what you did right. Okay, but for now we're on to Unit 6. And this first lesson is all about slope, which we talked a little bit about in Unit 5, but we're going to be digging a little bit deeper. So this unit is all about linear functions, okay? A function is a fancy way of saying a graph, okay? And linear means straight. So all of our lines, all of our graphs in this unit are going to be straight lines, easy peasy. Slope is how steep it is. So if you were climbing up this mountain, you'd be out of breath. This one, it's a decline. You'd be running down this mountain very, very fast. Okay, so slope is like saying steepness. Last unit, we learned how to find the rate of change. Okay, rate of change is a fancy way of saying how steep the line is. Rate of change is the same thing as slope. So slope, there's a few ways we can think of it. We talked about rise over run. Okay, so slope is how much your graph moves vertically divided by how much your graph moves horizontally, okay? Or another way of thinking about it is vertical displacement, I'm thinking of the French word, displacement divided by horizontal displacement. Okay, so let's do some examples here. So find the slopes of the given line segment. So I want to find the slope of this line. To find a slope of a line, you have to find two perfect points. What I mean by perfect is, see these grid marks here? You have a whole bunch of grid marks going vertically and horizontally. I want to find a perfect point where the grid marks cross and the black line also crosses. So that's why I put a point at A. That's a perfect point. I'm going to zoom in so you can see what I mean by perfect point. This point right here is the intersection of two grid lines and the graph. Okay, like for example, that right there would not be a perfect point because it's not an intersection of the two grid lines. Okay, the other perfect point is right there. That's an intersection of two grid lines plus the line passes through that exact intersection as well. So to determine the slope, all we do is travel from A to B. And this is going to be a little bit of a review for you. So to get from A to B, I have to hop 1, 2, 3, 4, 5, 6, 7. I have to hop 7 units up. And then I have to go 1, 2, 3, 4, 5, 6, 7, 8 units over. So I went 7 units up. So I wrote that there, 7 units up and 8 units to the right. So my slope is rise over run. So my rise is I went 7 up. So my rise is 7 up, and then my run is 8 to the right. So your slope, therefore, is your rise, 7 up, divided by your run, 8. And they are both positive because going up is positive and going to the right is also positive. Okay? So here we're going to look at where it's negative, an example of a negative slope. So same thing, I find my two perfect points. So right here is a perfect point and right down there is a perfect point as well. There are some other perfect points throughout, I believe, but I just drew these in for you. We'll use these ones. So to get from A to B, we find our rise first. So to get from A to B, we're actually not rising. We're going to be going down, and that's okay. We have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units until I'm in line with B. So because I went down 12, it's going to be negative. So my rise is actually a decline. That's why I put the negative. So it's negative 12 over 1, 2, 3, 4, 5, 6, 7. I went to the right 7. Going to the right means positive. So my run is positive 7. So if I do my slope and I do my rise on top, my rise is negative 12 and my run is positive 7. And there you go. You can't reduce that fraction at all, but if you could reduce it, I want you to always reduce it. Okay. So here there are 4 types of slopes. Just a little review here. There are 4 types of slope. The positive slope. The positive slope is always going to be in that direction. So think of it like you're climbing up a hill, or think of it on a treadmill. Okay. If you're ever on a treadmill in phys ed, if you were at a steepness like this, your incline on the treadmill would be like +4 or +5. It'd be going up. Negative slope is like you're running down a hill. Okay, you're on a decline. Zero slope, a zero slope is a perfectly flat line. Okay, I'll write that in. So again, think like a treadmill. If you're on a treadmill and you're completely flat, your incline is at 0. And undefined slope is a completely vertical line. Okay, so again, think of a treadmill. If Mr. Nielsen or Mr. Kozine or Ms. Schmidt asked you to put your treadmill to this incline and walk on it, well, you couldn't do it. You're not Spider-Man, okay? So that's why we say a vertical line is undefined. It's kind of like it's impossible, but we use the word undefined in math. Okay, so here, draw a line segment with a given slope of 7 over 5. So for all of these questions, we're just going to start at the origin. Okay, so I'm going to write that in here. Start at origin, because we need a starting point for all of our graphs. Okay, so the origin is the very center. This is the x-axis, that's the y-axis. So if I'm starting at the origin and I want a slope of 7 over 5, let me just center this page here. I want a slope of 7 over 5. That means I have to go up 7 and then to the right 5 because they're both positive. So from here I go up 7. I hope I have 7 spots. 1, 2, 3, 4, 5, 6, 7. So I end up at the very top. So that's my up 7, and 1, 2, 3, 4, 5. That is to the right 5. Now I'm going to do something here to blow your mind. Okay, 7 over 5 is technically the same thing as -7 over -5, because we know that 2 negatives make a positive. So really, if I add 2 negatives in, 2 negatives makes a positive. So that's why these are the same. So my options are to go up 7 to the right 5, or if I to add the 2 negatives in, I could go down 7 and to the left 5. That's what negatives mean. So another option is to start at your origin and go down 7, 1, 2, 3, 4, 5, 6, 7, and to the left 5. And look at that. All of the points are still in a nice, perfect line. Okay, so you can go up to the right or down to the left. It's technically the same thing, and your points all line up, so you know you did it right. Okay, over here, this one's a little bit trickier because I threw a negative in. Now, if it's a negative slope, that I know my direction is going to be going down, like a decline on a treadmill. You have 2 options here. We can put that negative with the 3, or we can put the negative with the 8. It does not matter. You get to pick. Okay? So if you put it with the 3, it's going down 3, but the 8's positive, so that's to the right. However, if you put it with the 8, that means the 3 is positive, so we'd go up. And the 8 is a negative, so we'd go to the left. Okay. I don't think I have 8 spots here. We're going to be going off the graph. My bad. So starting here, we go, if I'm doing this one first, I'm going to go down 3. 1, 2, 3. So that's my down 3. But to the right 8. 1, 2, 3, 4, 5, 6, 7. Sorry about that. I'm just 1 off. That's to the right 8. Okay, let's try the other one though. If I start here, I can also go up 3. So that's the other option, up 3, and to the left 8. 1, 2, 3, 4, 5, 6, 7, 8. So either way, that still creates one big giant line. So you can go any direction you like. Your lines or your points still can make a nice straight line. Okay. Here, determine the slope of the line that passes through point A, -5, -3, and point D, 2, 1. So let's draw those points first. There are 2 options of how you determine the slope when given 2 points. I'm going to show you both options here. So option number 1 is to draw the graph. So if I have 2 points here, I'm going to draw them out. -5 would be 1, 2, 3, 4, 5. This is the negative side of my x-axis. So -5, but then I'm at -3 for y. So -3 is 1, 2, 3 down. So where those 2 points meet is right there. And I'm going to label that point A. Then the next point is 2, 1. So I go to +2 on the x-axis and up to 1 on the y-axis, and that's point D. So option number 1 is to draw your 2 points and then do the hopping that we've been doing. So from A to D, I have to go up 1, 2, 3, 4. So up 4, and then 1, 2, 3, 4, 5, 6, 7. To the right 7. Okay. So rise over run would be, my rise is 4 and my run is 7, excuse me. Okay. And it should be a positive slope, which it is because I'm going up the hill. Up means positive. So that's option number 1. If you don't like drawing graphs, there is another option for you to use a formula. Now I'm going to zoom in here. So the formula is as follows: y2 minus y1 over x2 minus x1. And I'll explain what that means. So I'm just going to write down the 2 points we have here. So remember, our 2 points were -5, -3, and 2, 1. Okay, whoops. So remember, this is an x value, that's the y value, x value, y value. Now, this is the first point I give you. This is point number 1. So we're going to label them, that's x1, y1. This is point number 2, the second point I gave you. So that's why I put those little 2's. That's x2, y2. So all we do now is plug these into the appropriate spot in that formula. Okay, so y2 is 1. Then I go minus y1. Now be careful, I have a minus from the formula, and then y1 is already negative. So I have 2 negatives there. On the bottom, I have x2, which is 2, minus from the formula, x1 is -5. So again, we have 2 negatives. So really on top, it's 1 plus 3. Really on the bottom, it's 2 plus 5. So on the top, I have 4 over 7. And we got the same thing as the option number 1. So you'll see you'll get the same answer either way. In one case, you have to draw it. In the second case, you just have to do the math. And that's my son's little hand right there. Say hi, Elliot. He's sitting beside me learning math. Okay. Last question. Sweetie, I'm almost done, okay? Okay. Last question. Interpret the given graph to answer the questions. So here I have a graph of time. So we have 1 hour, 2 hour, 3 hour, 4 hours have passed on this graph. And on my left-hand side, I have distance in kilometers. What is the slope of the line is question number 1. Okay, so to figure out slope of the line, so here's our line right here. If we connect the dots, slope of the line, you have to choose 2 perfect points. So I have 3 perfect points. So choose any 2 you want and travel between the 2. 1, 2, 3, 4. 1, 2. Now, you have to be really careful here. I'm going to zoom in to show you what I mean. Elliot, just be quiet, okay? From here to here, yes, it's 4 ticks, but you actually have to look at the values over here. It's not just 1, 2, 3, 4, 5, 6. This is 24, and that's 48. So we actually went up from 24 to 48. That's actually moving 24 units. Sorry, guys, one sec. Okay, so we go up 24 actually, and then we have to look over here. We did 2 hops, but those 2 hops was actually only moving 1 unit. We went from 1 to 2. So we actually only moved 1. So again, yes, we moved 4 ticks, but those 4 ticks valued 24 units. And then here, yes, I moved 2 ticks, but those 2 ticks only valued 1 unit. So the slope of my line is 24 over 1, and we can just write 24. Okay? What does the slope represent? Well, the slope represents how much distance we traveled in a certain amount of time. So my rise is distance, and my run is time. How far did Yvonne travel in 1 3/4 hour? So we're assuming the person who did this little trek here is Yvonne. In 1 3/4 hours, so that's 1 hour, and 3/4 of an hour is 45 minutes. Okay, so this is 1 hour. That's 2 hours. This would be 1.5. So 1.34 hours, or sorry, 1 3/4 hours would be 1.5 plus half of a half. Okay, that's 1 hour and 45 minutes. So all we do is we travel up from there and see about how far she had traveled at that time. And we are at about, well, if that's 36.48, that's a gap of 12. So then that line would be 42. And I'd say we're about halfway between 42 and 48. Okay, so about 45 kilometers. How long would it take for Yvonne to travel 55 kilometers? Okay, so let's find 55 on the graph. So again, this is a gap of 12, which means this would, from here to here, would be a gap of only 6. Okay, so that would be 54. So 55 is just a smidgen above. So if we're just a smidgen above that 54 line, we go across. Okay, we get to about there, and all we do is look down and say, where are we around there? That's not quite 2.5 hours. That'd be 2.5 right there. So 2.5 hours is 2 hours, 30 minutes. We're just shy of that. Let's say 2 hours, 25 minutes. Okay, sorry about that. There you go. Okay, so you'll see the optional assignment on the website, and please email me or send me a reminder if you have any questions.